Hello, Professor. This is me, Sabrina Frost. Today I discuss about our week 5 presentation, bond valuation assignments. So I make a presentation and then I just discuss about the presentation. So I share my screen here. So our presentation is analyzing bond evaluation. Here I'm just discuss about the bond values and duration. So determining which bond will trade at a greater price and why it's necessary given to bonds like A and B have the same credit like rating, par value, and coupon rate, but different maturities like 30 years for bond A and 5 years for bond B. So maturity-based price comparison. So the correlation between the interest rates and the bond prices in inverse. So bond prices are the more vulnerable to fluctuations in interest like rates the longer the maturity, and in which that considering bond A has a 30-year maturity period, whereas B only has a 5-year maturity period. So bond A and B will be more susceptible to changes in interest rates. The values of both bonds will be near to their par value if market interest rates remain steadily. So here is the topic effect of raising interest rates, like the market values of both bonds and decline when interest rates and economy. So this is because the new higher yielding bonds start to seem more appealing than the fixed coupon payments. Bond A has a longer lifespan than bond B. Its price will decline more than the bond B's. So price change as a percentage. For bonds with a longer maturities, the percentage the price change attributable to changes in interest rates is larger. As a result, if interest rates rise, bond A's price will fluctuate by a larger proportion than bond B's. So I'm actually noted some numerical example, like let's assume the following par value P, $1,000, coupon rate C is a 5% because here is a bond, another bonds. Current market interest rate, which is defined by R. This one is 5%. For simplicity, we will use the present value formula for bond pricing. T is the number of years of maturity, C is the annual coupon measurement, and the R is the market interest rate. So here are some terms of mathematical, like bond A, 30 years of maturity, uh, initial price calculation, price with increased interest rate, like since R is 5%, the bond price is P, will be par at value 1,000. So the interest rate is a 66%. Bond B, like 5 years of a maturity, like coupon payment, since R 5%, the bond price P will be at par value like 1,000. So price will be increased, interest rate here 6%. So I just calculate bond A and bond B calculation. Percentage price change. Bond A. Calculate the percentage change from the initial price from the new price with R 6%. And bond B. Calculate the percentage from the initial price to the new price with the R 6%. Like as the topic, the given the longer duration of a bond A, the percentage price change will be the higher compared to the bond B when interest rates increase. So now let's discuss about conclusion. Because bond A is a long term than other bonds, it will trade at a premium is a steady interest like rate environment. And increase in interest rates will result in a price fall of both bonds, but bond A will lose value more dramatically. Because of its longer maturity and greater sensitivity to interest rate changes, bond A will see a larger percentage price shift in the event that interest rates rise than the bond B. Providing sources of support. Here I include two providing sources of support according to Investopedia. Long-term bonds are more susceptible to changes interest rates because of their long length and increase likelihood of such a swing over an extended period of time. And the second one is a duration concept, like which gauges bonds price sensitivity to fluctuations in interest rates is emphasized by fidelity. Bonds with longer maturities and smaller coupons have longer durations, which increases their volatility in circumstance which interest rates fluctuate. So this is my bond analyzing evaluation assignment. And yeah, that's all. And thank you.